Hey guys, so in this video I'm going over lesson 2.1 for simplifying radicals and imaginary numbers. So what in the world are we talking about radicals? Well, you kind of have already been exposed to radicals, but it's been in the form of prime factorization. So let's remind ourselves what that means. So if we're given 64, we want to say, okay, what times what gives us 64? And yes, there are many different ways you can do this. That you can choose 2, you can choose 8, but let's start at the very lowest number we can choose, which is 2. So we're going to do 2 times 32 gives us 64. Now 2 is prime, so we're going to circle it. 32 is not, so we're going to keep going with 32. What times what gives us 32? 2 and 16. 2 is prime, 16 is not, so we're going to keep going. What times what is 16? 2 and 8. 2 is prime, 8 is not, so we're going to keep going. What times what is 8? Hopefully we know. 2 and 4. 2 is prime. 2 times 2 is 4. And 2 is prime. Remembering, prime means that only itself and 1 can go into it evenly. Meaning for 2, 2 is prime because only 1, you can take 2, divide it by 1, and it be a whole number. Or you could take 2 and divide it by itself and it still be a whole number. So that's the prime factorization of that. What if we looked at this 84? So we're going to start with the smallest number that can go into it evenly. Meaning if we took 84 divided by 2, we would get a whole number. We would get 42. Then we're going to take 42, factorization out, 2 times 21, and then 3 and 7. So our 2 is prime, our 3 is prime, and our 7 is prime. So we're going to use this while we're simplifying radicals. But let's look at parts of radicals first. So the first thing you're going to come across is the coefficient. The next thing you're going to come across is the index. The index is going to be that small number in front of this symbol here. The symbol there is the radical itself. And then what is underneath the radical is called the radicand. So the index will determine how many of the same number in a prime factorization will make up one group. For each circled group, one of the number grouped will be multiplied by the coefficient. Here we go. The coefficient in front of the radical. So you guys can read this. I know that it does not mean much if I just read it. So I'm going to actually show you what those notes mean. So remember perfect squares. So perfect squares are going to be your friend. What perfect squares mean is if we have like 4. So perfect square of 4 is 2 times 2. So there's exactly 2 numbers of that multiply itself to get to that number, to that perfect square. Another example is 9. What times itself is 9? 3 and 3. Another example is 16. 4 and 4. Another one is 100. 10 and 10. So on and so forth. You could do it with any number. To be a perfect square, the exponent of a variable, so we're talking about a perfect square of a variable, the exponent has to be even. So that means if we had x and then to an even exponent, so let's say 2, that means we would have x times x. And if we had, let's say, x to the 6th, we would have x to the 3rd times x to the 3rd. So on and so forth. As long as the exponent was even, it would be a perfect square. So let's go through how we're going to simplify these radicals. First, I want to do the prime factorization of it. So 25, we have 5 times 5. Well, 5 is prime. So that means we have, under the radical, we have 5 times 5. So if there is not a index indicated, then the understood number is 2. So that means we're going to group the numbers. 2 numbers of the same, that are the same, can get grouped and moved out of the radical. That means we have plus or minus 5. So let's do another one. 36. The index is not indicated, so we can assume that it's 2. So when we factor it out, we have 6 times 6. Now, we can keep going if we really wanted to. We can keep going and say 2 times 3 and 2 times 3 if we really want to. But the only thing we're worried about is that we have 6 and 6. So we have the square root or the radical of 6 times 6. Well, if the index is 2, that means we're grouping 2 of the same. They're moving out and becoming plus or minus 6. Now, the reason why it's plus and minus is that let's take this 36, for example. If we had the radical of 6 times 6, we could also have the square root of negative 6 times negative 6. And it still would give us positive 36 on the inside of the radical. So when we moved it outside of the radical, we have to include that plus or minus part. All right, go on. So for the 100 and the square root of 100 and the square root of 49, pause the video and see if you can do it on your own. So the square root of 100, you should have gotten plus or minus 10 and plus and minus 7. So then we move on to taking the square root of variables. So the hint of this is dividing the exponent by 2. So essentially what we have is the square root of a times a times a times a. 1, 2, 3, 4, 5, 6. Essentially that's what a to the 6th means. And our understood index is 2. So that means we're going to group it in 2's. So that's going to move out as 1a. This group is going to move out as another a. And this little last group of 2a's is going to move out and become 1a. Now in this case, there's nothing left underneath the radical. So we simply just have plus, or a times a times a, which is a to the third. We still have to throw in that plus and minus. So that would be our answer for this, the square root of a to the 6. Now what that hint means is that every single time when it is even, you can take that 16, or you can take that exponent, divide it by 2, and you would end up with plus or minus m to the 8th, and that would be your answer. It always works when your exponent is even. When your exponent is odd, you're going to have something left underneath the radical, and we'll get to that. But for now, pause the video and see if you can do those last two, the square root of y to the 10th and the square root of a to the 2nd. So you should have gotten plus or minus y to the 5th and plus and minus a. Excuse me, guys. So let's simplify. So we got a few in here. I'm gonna do the main ones I want to hit. So let's do negative square root of 100. So for 100, it is a perfect square. We have 10 and 10. So we have negative square root 10 times 10. Well, the understood index is 2. So that means we're going to group these two 10s together and move them out. Well, when we move them out, don't let this negative fool you. We have negative, and then we have a plus and minus 10. Well, this negative does not mean much when we have this plus and minus sign. So we simply just have plus and minus 10, or positive and negative 10. If the negative is on the outside, it does not mean much. It only means something if it's on the inside, and we'll go over it in this lesson. So let's hit, I want to do this one at the bottom with you. So we're going to take it one step at a time, and we're going to split it up. So we've got this part, I don't want it that long. This part, and that part. So the 49 is a perfect square, so we have 7 and 7. For a, we have 4 divided by 2, which is just 2. And then we have 12 divided by 2, which is 6. So underneath the radical, we have 7 times 7. We can do it multiple ways. You can go ahead and say on the outside we have a to the 2nd and b to the 6th. Or you can write it all out. 1, 2, 3, 4, and then 12 b's, which would get a little ridiculous, but you can always do that. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. And all of that would be under the radical. And then you have a understood index of 2, so you would move all of those out. A little saying that I like to use is 2 of the same things underneath the radical get married and move out of the house. So that's as long as there's not an indicated index, it's always 2. So they get married and move out of the house. So on and so forth. So you end up with 1 7 on the outside. 1 7 on the outside. 2 A's on the outside. And 6 B's on the outside. And that would be your answer. So pause the video and see if you can do the other 4 in this section. So you should have gotten plus or minus 4 plus or minus a to the 4th plus or minus 3a and plus or minus a to the 3rd, b to the 5th. Remember, if I ever go too fast or you've gotten lost, you can always pause the video and email me and ask specific questions. Going on. So what if our index is not 2? What if it actually indicates a specific number? So that means we can't just stop where our prime factorization is with our perfect squares. So that means we're going to take our 16 and we're going to take it all the way down. And actually, I'm going to run out of room if I do it there. Hold up. So I've got 16. What times what is 16? 2 and 8. 2 is prime, 8 is not, so I'm going to keep going. 2 times 4. 2 is prime, 4 is not. 2 times 2, my 2's are prime. So that means underneath of my radical, I have 2 times 2 times 2 times 2. So I'm looking for a group of 4 of the same number, the same variable, underneath that radical. So I have exactly 4 of the same number. They're going to move out of the house and become 1, 2. And that's always a plus and minus. So let's look at another one. Let's take our 81. Our 81. What times what gives us 81? Well, smallest number. You can start either way. Let's start at 9. So let's say you can only think that 9 times 9 is 81. Well, then we have to separate out our 9. So 3 times 3 and 3 times 3. And 3 is prime. So this becomes 4th root of 3 times 3 times 3 times 3. A group of 4 of the same number. So 1, 2, 3, 4. And they move out of the house to become a single 3. And that's always plus and minus. Alright. Going on. So there is a trick to this. I want to show you without the trick for a second. So I'm going to do just the variable part of this one before I do that 7th root of x to the 21st. So if I just had the 4th root of x to the 4th, that means I have the 4th root of x times x times x times x. So I'm grouping 4 of the same and moving it out. So it becomes a single plus or minus x. Now, kind of like that trick when our index was 2 or understood 2, you can always take your index and divide it by the exponent of the variable. And as long as that's a whole number, that's what you're left with. So the reason why I skipped it is that if you sit here and write out all 21 x's and then group them in 7s, you would end up with 3 x's on the outside. Now just take that 21, divide by 7, and you get that 3 that you need. Okay. Same thing with our 5 and our 30. We can take our exponent, divide by our index, and get how many x's are left, how many x's are moved out from underneath the radical. So we get 7, so that means 7x's plus or minus. And when I say 7x's, that means I have 7 times 7 times 7. There's 7x's multiplied together. 3, 7. Okay, I'm going to do one more that actually has numbers and variables. So we have 2 different things going on. Now I'm going to separate them. There we go. So 8 I'm going to separate. So we've got 2 times 4. 2 is prime, so I can stop there. 4, I've got 2 times 2. I can stop there. Then I have x to the 9th. So x to the 9th, I'm going to use my index to divide that exponent. That exponent is 9. And I'm going to divide by the index indicated. So I get 3. So that means on the outside, for my answer, I have 3 x's. And for my 8, I have third root of 2 times 2 times 2. Group 3 2's together and then move them out so it becomes a single 2. And we throw that plus and minus out front. So I kind of already done half of the work. So pause the video and see if you can do these 2. Don't worry about the last one, just do, let me set it up for you. Figure out what this one would be, and figure out what this one would be. Do that now. Pause the video and attempt this problem and see if you can fill in those green spaces. So the first space, you should have gotten plus or minus 2x. Now, you can put to the first power, but you don't have to because x to the first power is the same thing as x. Now, the second blank I set up for you should have gotten 5x to the third plus or minus, and plus or minus 3x. So you're going to multiply these. So the number is going to multiply each other. So we're going to get 15 plus or minus. And then we have x to the third times x to the first. Well, when we're multiplying, we're adding the exponents. So we get x to the fourth. And that is our answer. That is our final answer for this one. So what if it's a non-perfect square? So let's look at this 20 underneath the radical. So we're going to start by prime factorization. So what times what is 20? Again, you don't have to be elaborate. You can start off with just 2 and 10. You know 2 goes into it because it ends with an even number. Or think of it as you know 10 goes into it because it ends with a 0. 2 is prime, 10 is not, so you go 2 and 5. 2 is prime, 5 is prime. You can't divide it by any other number but 5 and 1. So that means under the radical, and I'll even put it down here, we have 2 times 5. There is no indicated index, so we can assume it's 2. So we're looking for a group of 2 things that are the same. There are 2 2's. They move out of the house and become 1 2 or a single 2. The 5 stays underneath the radical. So our answer is plus or minus 2 times the square root of 5. So pause the video and see if you can do the 27, the square root of 27. The answer should be plus or minus 3 times the square root of 3. Again, if you have questions, you can always pause the video and email me, or just take note and ask your question during the live video or the live classes. Moving on, a few more. So I've already done numbers. I want to make a point to try to do these variables. All right. So there are multiple ways to look at this. You can always write all of them out, or realize that your index is a 2. That means we're looking for an exponent that is even, so we can divide it by 2 and just use the trick. So I'm going to show you both ways. One, expanding it completely. The index is 2, so we have one group, two groups, and one left over. So we have a times a with one a left inside. So that means we have a squared times square root of a. Other way is that we want this 5 to equal still a to the 5th, but we want the exponent to be even. So we're actually going to take away 1a and put a to the 4th together. So that way, just let me change the color so you can see it. Just this a to the 4th, we're going to take the exponent, divide it by the index. We're going to have a to the 2nd on the outside with that a to the 1st left over. Either way is fine with me. Either way, our answer is plus or minus a to the square root of a squared to the square root of 8. So pause the video and see if you can do the other problems in this section. Alright. So the 48, square root of 48, you should have gotten plus or minus 4 times square root of 3. 45, you should have gotten plus or minus 3 times square root of 5. 50, you should have got plus or minus square root of 5 times square root of 2. Down here, you should have gotten plus or minus x to the 4th times the square root of x, and plus or minus x times square root of x. Alright. Moving on. I do want to hit one of these harder ones. So let's look at this one. Obviously, that is why you cannot always rely on expanding everything. So we're going to separate this out. We're going to take care of the 80. We're going to take care of the exponent of 100. And then we're going to take care of the exponent of 49. So let's do that. 80, we've got 8 and 10. Then we've got 2 and 4. And we've got 2 and 2. 10, we've got 2 and 5. So that means for the 80, as far as the 80 goes, we have 2 times 2 times 2 times 2 times 5. Index is 2. It's understood because there's nothing there. 2 2s come out as a single 2. 2 2s come out as a single 2. And the 5 is left over. So we have 2 times 2 and a 5 left over. So that means number-wise, we're going to have plus or minus 4 and underneath the radical, we're going to have a 5. Now, what in the world with these variables? So we have an even exponent. Because it's even and our index is even, we can do 100 divided by our index, which is 50. So that means there's going to be 50 x's on the outside. Let me move those things over in a second. So we had 4, and we had x to the 50. And that's all of them. Now with this y to the 49th, we're going to take one of the y's away and separate it from the other ones. We're going to make it y to the 48th. This way we can take the 48, divide by the understood index, which is 2, and get 24. So that means on the outside we have we have y to the 24th, and we have one lonely y on the inside, and that is our answer. Alright. So I kind of hinted at it before, and you can look at some of these notes later, but imaginary numbers are what you get when you take the square root of a negative number. This imaginary number is going to be represented with an I. So if we take the square root of -1, it would become just simply I. So we're going to separate out these numbers like we did previous. Except for if there's a negative, take out that -1 first. So this is how I would do it. -1 times 9. -1 is prime. Then you would do your 9, so you would have 3 times 3. So that means underneath your radical, you would have -1 times 3 times 3. Your index is still 2, but that -1 is special. It comes out as your I. And then your group of 2 3's come out. So you would have plus or minus 3, and then that special I, or that imaginary I. Now let's do some more examples. So what if we had the square root of -25? So I take out that negative first. Then we would have 5 times 5. So we have the square root, -1 times 5 times 5. That -1 comes out as I. And then our understood index is 2, so those 2 5's get grouped together, move out as a single 5. And that would be your answer. Now, let's do this one. Remembering, I'm skipping this one because the only thing different about this one is that negative out front. Negative out front does not matter. Inside it matters, outside it doesn't. So what if we had this one? We're going to start on the inside, so -49. And then we would have 7 times 7. So that means we have 2 times the square root, -1 times 7 times 7. So that -1 is going to come out as I, so we have 2I. And then we have the group of 7 comes out as 1 7. And then there's nothing underneath the radical. So there's all multiplication on this outside. How you can remember, if you were to read this, the original problem, it's 2 times the square root of negative 49. So when you move things out, it's multiplication. So 7 times 2 is 14, and that I stays there. And that is your answer. So pause the video and see if you can get the square root of negative 100 and negative times the square root of negative 81. Pause the video now. So you should have gotten plus or minus 10i and plus or minus 9i. Going on. So I'm going to go to the harder one. I want to go to this one. Excuse me. So negative 1 times 9. 3 times 3 gives us 9. So we have negative 2 over 3 times the square root of negative 1 times 3 times 3. So negative comes out as I. 3's come out as just a single I. So I'm left with negative 2 over 3 times a single 3 times an I. And all of this is plus and minus, so there's a plus or minus there. If you really want to, and that plus or minus throws you off, it means that we have a negative 2 over 3 times positive 3. We also have a negative 2 over 3 times negative 3. So that's going to give you 2 different answers. This one's going to give you, a negative 2. This one's going to give you a positive 2. Either way, you end up with plus or minus 2 in that I. Moving on. Again, I'm trying to pick the hardest ones because I know you don't want to hear me go through every single one. So let's go over this one. So I'm going to take this one step at a time. Instead of writing it as is, we can agree that this negative is kind of like a negative 1 times 16 over 25. So we're going to take this negative 1 out. And it's going to become I. So we're going to have an I on the outside. Then I'm going to take the square root of 16 and the square root of 25. Well, the square root of 16 is a perfect square, so we have plus or minus 4. 25 is also a perfect square, so we have plus or minus 5. So that means we have our I on the outside, and we have our 4 over 5 plus or minus. And that is how you do the fractions. So what if there's a number and a fraction? So like this one. So we're still going to do the same steps. We're still going to take our negative out. It's going to become an I. And then our 49, so we have the square root of 49, which is 7 plus or minus 7. And then we have the square root of 64, which is plus or minus 8. So we have 4i times our 7 over 8, and all of it's plus or minus. So our 4 times at 7 over 8. So if you really need to, you can switch that 4 over 1 times 7 over 8. Excuse me. So you would simplify, and you would get plus or minus 7 over 2 times I. And that would be your answer. So pause your video and see if you can answer the rest of this section. So your first answer should be plus or minus I. Your next answer should be plus or minus 1/2 I. Next one should be plus or minus I times square root of 3. Next one should be plus or minus I times square root of 10. Plus or minus 2I times square root of 5. Plus or minus 10I times square root of 3. And plus or minus 10 times I times square root of 2. So remember, if you have any questions, you can always email me immediately, or you can wait till the live class and ask it during the class.